Good morning, all of you. So, as we know that we are studying presently Gravitation chapter. So, in last class we have been discussed what is gravitational constant G and what is the units of gravitational constant. Is it yes or no, guys? So, what is the units of gravitational constant? Anybody? What is the units of gravitational constant? Anyone? Please respond me. Units of gravitational constant. So what is the symbol of universal gravitational constant? G. Is it yes or no wrong? So as we know formula, F is equals to the force of attraction. F is equals to G into M1 into M2 divided by R square. Is it yes or no wrong? Please respond me. So from that, G is equals to, we know, force into distance between them, square of distance between them divided by mass of M1 into M2. So G units is equals to Newton meter square divided by kilogram square. Is it yes or no, guys? This is what we have been studied in the last class. Respond me. Now, today's class, we are going to study one more interesting and important thing. Good morning, Laksha. That is what is this G value? Value of gravitational constant and how to calculate it. That is all we'll discuss. Shall we discuss it now, guys? Please respond me, Ra. Now, let us go with that. Value of gravitational constant G. All of you keep hitting. Value of gravitational constant G. Value of gravitational constant G. Now this value, if we'll see how to calculate it and what is that value, let us all discuss now. So if you'll observe very carefully, guys, as we know what is the G formula? G equals to what, guys? G equals to what? M1 into G equals to F into R square divided by M1 into M2.
M1 into M2.
You are not responding, I don't get interest to teach you. Now, observe, if the masses M1 and M2 of the two bodies are 1 kg each, how much, Ra? Let, how much? Please respond me.
1 kg, sir.
Yeah, that is. So, let if masses of M1 and M2 are 1 kilogram each, and R is equals to 1 meter, then please substitute in the formula and you tell me what is the equation used to get. Everybody, then what is the equation? If you substitute in the formula, what is to get? Nobody will say.
1 only.
What is that? Then what is the formula? G is equals to F into R square divided by kilogram square. So M1 into M2. So substitute the values, what it will come? F we don't know. F into R square means what? 1 square divided by 1 kilogram into 1 kilogram. Which is equals to what? F. Understanding? Into 1, F only. Divided by 1 into 1, 1 only. Is it yes, guys? Please respond me. Nobody is answering. So, if bodies will become, understanding, if the masses will become 1 kilogram and 1 kilogram and the distance between them will become 1 meter, then you can see G is equals to what it is. G is equals to what is becoming?
Yes.
That is what? Understand, Sai, Maitreyan, Monish?
Yes, sir.
Yes, sir.
If masses of the two bodies become M1 and M2, understanding, both will become 1 kg and the distance between them is how much, Sai? 1 meter. Then gravitational constant will become is equals to force of attraction between them. Is it yes or no, guys?
Yes, sir.
Yes, that is. So both M1 is equals to 1 kg and M2 is equals to also how much, guys? 1 kg. And
1 kg.
distance between their centers, how much, Ra? Distance between their centers is equals to how much? 1 meter. So
1 meter.
In this situation, what will become Ramanish? Gravitational constant G is equals to force of attraction. Any doubt in this? Please respond me. So, if you
No, sir.
these gravitational constant G numerically equal to the force of gravitation which exists between two bodies or unit masses kept at a unit distance from each other. Do you understand, guys? That is the meaning of this one. So this gravitational constant, whatever it is there, the value, whatever it is their value, the G value, which is equals to the, which is what, guys? Which is equals to the gravitational force of attraction, the gravitational force of attraction, which is what? Which is having a masses of how much, guys? Masses of 1 kg.
1 kg.
1 kg. And the distance between them is how much? Distance
1
between
meter.
1 meter. That is what we should call it as gravitational constant. What we should call it? Gravitational constant.
Gravitational constant.
This value of universal gravitational constant G has been found, understand, has been found by Henry Cavendish. Hurrah! Henry Cavendish, understand? And he has been done
Yes,
an experiment called as simple. What is that called as? What is that experiment called as, guys? Anybody? Simple balance. What we should call? Simple balance.
Simple balance.
Do you remember, Shruti? Yes or no? Henry Cavendish, and that experiment also I will show you now. And he has been found. He has been taken in two bodies, simple balance. Two bodies of masses, how much, Ra? Two bodies of masses, how much, guys? 1 kg and 1 kilogram, and has been kept a distance between them is how much, Ra? 1 meter. And the force acting between them is equals to what? The gravitational constant. That is what he has been found. He has been set up. That is a method called as Cavendish method. What we should call that method known as? Cavendish method. Because he has been found. Mr. Henry Cavendish is found this gravitational constant value. That value is equals to, if we'll observe, 6.67 into 10 power minus 11 Newton meter square per kilogram square. What we should call, guys? Newton meter square per kilogram square. Now, it is minus 11. Minus 11, correct? So you tell me, if we'll take any two ordinary objects, the force between them is very, very weak or very, very strong? Elamukil, Laksha, very, very strong or very, very weak? If we'll take the G value, which is equals to, I am saying that 6.67 into 10 power minus 11 Newton meter square per kilogram square. So it is minus 11. So the force is very, very weak or very, very strong? Very, very weak, because it is minus. Yes, guys, please respond me. Maitreyan, Shruti, understand? So the force acting between them, understand, Varshini? The force acting between them, two bodies, is very, very weak. That is what? The gravitational constant between any two bodies, understand, having a mass of 1 kilogram and the distance is 1 meter. That is, G value is equals to force of attraction between them. So this force of attraction is very, 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 very less. Understand, guys? Very, very weak. Will you remember? Please respond me. Yes. Now let us go with now another thing. So now let us say, I want to say the statement correct. So if you will consider mass of the M1 and M2 are 1 kilogram and the distance between them is equals to how much, Ra? R is equals to 1 meter. Understand? But our textbook, they are taking distance is equals to what, Ra? Distance, our textbook, they are taking what, guys? Distance
D, sir.
equals to D. But Varshini, don't get confused. Your teachers, maybe they will say distance is equals to D, but it is R also we can take. R is a standard books and all, they will follow R. But our textbook, they will show D. Both are correct. Okay, guys? Understand, Ra?
Yes, sir.
Everybody, that is. So, what do you mean by G equals to F? What do you mean by G equals to F here? That is, the gravitational constant G is numerically equal to the what? The force of gravitation, which exists between how many bodies, Ra? Which exists between
Two bodies.
bodies of. What is the mass, Maitreya? Unit masses. Unit masses means 1 kilogram mass.
One mass.
And kept a distance of from how much? Unit
1 meter.
from each other. So, with at that situation, the G value, whatever it is present, understanding, Ra, which is equals to how much? 6.67 into 10 power minus 11 Newton meter square per.
Newton square kilogram square.
Please write the statement. Understand, Ra? So F is equals to G means in the sense of the G value has been found is equals to how much, guys? 6.67 into 10 power minus 11
Minus 11.
Newton meter square per kilogram square. Never write like this. Never write like this. Anybody, I am saying you. Understand, Shruti? Please respond me. That is. So always you should write like this only. For cancellation, it is easy. No, don't use this one. So till here, any doubt, guys? Clear?
No, sir.
Sir,
Now, I will show you the experiment also. Later, I will explain you which kind of balls he has been used. This are two balls, two masses, two objects. What kind of balls he has been used, and that what is that experiment name called as Cavendish method. What we should call Cavendish method.
Cavendish method.
That
Cavendish method.
what is that balance called as, Elmokil? Elmokil, what is that balance called as? Simple balance. What we should call?
Simple balance.
Understand, Ra? Now, observe this picture, all of you. Gravitational constant, that number gives the strength of gravity. What it will give, guys? That gravitational constant number will give the strength of gravity,
Strength of gravity.
force of attraction present between the two bodies. That is what we can say. Equal distance means 1 meter distance and equal unit masses. Is it yes or no, guys? Please respond me. So,
Yes, sir.
the strength
Yes,
of the force of attraction, strength of force of attraction between them. That force of attraction only we can call force of gravitation. What we should call? Force of.
Force of gravitation.
Understand? Now, if you'll observe here the experimental setup, here are you able to see the two balls here? This is what the experiment called as Cavendish method. What is this method?
Cavendish
Cavendish
method.
method.
Cavendish
Yes,
method.
sir.
So I think you may be notice here the balls. Have you noticed it, guys? Balls. This is what
Yes, sir.
which is having a equal mass of how much, Ra? 1 kilogram unit.
1 kilogram.
So now, Yelmokil, what is that page number? Say to others also. Let them highlight that Henry Cavendish and all. Where it is? Page number? Shruti?
Sir, wait, sir.
Okay, you say. All of you highlight that in our textbook also. Scientist name and the experiment name. Simple balance. That experiment name called as simple balance. And this experimental setup is called as what? Cavendish method. What method? Cavendish method.
Sir, page
For what
number
purpose?
134.
Determining the value of universal gravitational constant. Determining the value of universal gravitational constant. What is the page number?
134, sir.
Page number
134, sir.
Page number 134, right side corner, second paragraph, I think. Second paragraph or third paragraph. You may be having Henry
The
Cavendish.
second only, sir.
Yeah, second
Sir, yesterday
paragraph.
unit.
Henry Cavendish has been used simple balance to find the G value. Like that is there. Please highlight that. Is it okay, guys? You also. Everybody, Alana, everybody highlight that. Laksha. Okay, guys. Respond me.
Yes,
Yes,
sir.
sir.
Observe very carefully here. What happened means here, the value of gravitational constant has been performed by a careful experiment with two gold balls. Understand, Ra? So Henry Cavendish has been done with what? Two gold balls. This balls is what? Henry
Gold
Cavendish
ball.
method. Gold balls. That is you should remember, because your textbook no explanation, because higher classes only will study that, but you must having this knowledge. So Cavendish method. So here if you'll observe very carefully, he has been used two gold balls. So this two heavy gold balls were suspended near each other by strong, understanding, but delicate threads. How much? By strong and delicate threads.
Delicate
The
threads.
force between them, the force between the two gold balls was then measured, and the force, understanding, the masses of the gold balls and the distance between them, the value of G was calculated by using Newton's gravitational formula. And we have kept two balls, and the distance between them, they are hanging too freely with the help of strong but delicate threads, and with the help of G value, with the help of Newton's gravitational formula. What is that formula? G is equals to what? G is equals to, sorry, for F is
Force and
what? Force is equals to G
equal to
G
G into R square
M1 into
M1 into
divided
M2
by
divided by
R
R
square.
square.
R
With
square.
the help of this formula, at that situation, two gold balls has been hanging here freely with the help of, with some distance between them. So there, understand guys, here it has been the experiment with the gold balls gave the value of gravitational constant G, which is equals to how much, Ra? 6.67 into 10 power minus 11
Minus
Newton
11
meter square per kilogram.
kilogram square.
Understand, guys? Now, many times you can say your textbook, they will give you 6.673 also. 6.673 into 10 power minus 11 Newton square meter per kilogram square. But some textbooks, they will give you only 6.67 into 10 power minus 11 Newton meter square per kilogram square. But numericals, while you are solving the numericals, all of you should remember, while you are solving the numericals, Shruti, more simplify, I am saying you, just directly remember 6.7 into 10 power minus 11 Newton square meter per kilogram square. Understand, Elamukil, Tamil Selvan, Darun?
Sir.
Understand, Ra? Remember, what is the for numerical purpose? While you want to solve the numerical, Sai, understand, Sai? You have to remember G value is how much? 6.7 into 10 power minus 11 Newton meter square per kilogram square. So this is minus value, very, very less force. Is it yes or no, guys? The force of attraction.
Sir.
Force of attraction is very, very negligible. Understand, guys? Very less. That is, you should remember. So this is what the experiment. What is the method, Sai? Which method Henry Cavendish used to find the G value? Henry Cavendish method. What is that? Cavendish method.
Cavendish method.
So this is what about the G value. Now, this G value you can take, understanding all the cases, in all the cases, the value of G, which is equals to how much, Ra? 6.67 power minus 11 Newton square meter
per kilogram square.
M1 and M2 are the how many bodies? Masses of two bodies.
Two bodies.
Two bodies, and R is equals to what? R is the distance between the centers of two bodies. Distance between the centers of
Two bodies.
very, very important question for your MCQs. Is it a vector quantity or scalar quantity? Alana, Laksha, everybody remember. Is it a vector or scalar quantity? That is what my question. Anybody? Can you say? Is it a vector or scalar quantity? So this
Vector quantity.
G is a vector or scalar? Vector or scalar quantity? Can you able to say
Vector quantity, sir.
Vector quantity.
why vector? Anybody can say because?
Sir, it also
Sir, it
shows
also is
Yeah,
distance.
it is acting between the centers of two bodies. Is it yes or no? On the line of axis, center. On the body center, it is acting. That is why it is called as what? Vector quantity. Understand, guys? It is acting between the force of attraction between what? The centers of line of joining of two centers. Is it yes or no, guys? Understand, Ra? The line joining the centers of masses of the two bodies. That is the reason it is called as vector quantity. What we should call, guys? Vector quantity.
Vector quantity.
So the force of gravitation. Understanding, guys? Force of gravitation is a vector quantity, not a scalar quantity. It is the vector quantity because why, guys? Draw this diagram and you can say it is acting between where, Ra? It is
In the
acts
center of
along
two
the
bodies.
line joining the centers of masses of the two bodies. It acts line joining along the centers of what, guys? Centers of two bodies.
Body.
That
They
is
have two bodies.
that is why this force of attraction, force of gravitation, what we should call, Ra? Elmokel, we should call it as vector.
Vector quantity.
That is
Vector
usually.
quantity.
Any doubt in this? Any
No,
doubt?
sir.
No, sir.
No, sir.
Let us calculate.
No, sir.
Let us calculate. As we know, this force is equals to how much value? We'll calculate it now. So let us take gravitational force between objects of small size and big size. What is that? Objects of small size and big size. Both will. Is it okay, guys? Now, for example, please all of you keep heading. Gravitational force between objects of small size and big sizes. Gravitational force between gravitational force between objects of what, guys? Objects of
Small size and big size.
small size and big sizes. Any doubt means you ask me. Big size, small size and big size. Okay, guys. Now let us see. Suppose two balls of 1 kg each are placed with their centers 1 meters apart. Then what is the force of attraction each other with the force of given? Can you able to calculate it? Please tell me. Suppose two balls of 1 kg each. Let me take. Suppose what is that? Two balls of 1 kg each. Two balls of 1 kg each are kept 1 meter distance. 1 meter distance between them. So what is the force of attraction? Anybody calculate fastly and tell me what is the F is equals to? Please do fastly. F is equals to what is that? Please respond me. What is the formula? At least formula you tell me. What is the F equals to?
Sir,
F is equal to G into M1 into
M2 by
M2
R
Into M2 divided by R square.
R square. So we know G value. How much is the G value? 6.7.
6.7
6.7 into
to 10 power minus 11
power minus 11.
meter square per kilogram square, which is equals to mass is equals to how much, Ra? Mass equals to how much? 1 kilogram into 1 kilogram. Is it yes or no, guys?
Sir.
Yes, sir.
Yes, sir.
Yes, sir.
Whole square. So next what will come? 6.7 into 10 power minus 11
Minus 11.
meter square
10 meter.
per kilogram square into kilogram. 1 into 1 how much, Ra? 1 kilogram
1
square.
kilogram.
Kilogram square.
Correct. So now which is equals to what? Kilogram square will get cancelled. Square meter will get cancelled, which is equals to what? 6.7
6.7 into 10
power
power minus 11 Newton.
This is what? This is what, guys? Force acting between them. You understand, guys? Do it, all of you. So the force acting between them, if the masses, if you consider suppose two balls of how much mass, Ramavanish? Darun, understand, Darun? Each mass
1 kg.
equals to what? 1 kg. And the distance between them is how much, Ra? Distance between them is 1 meter. Understand, guys? Yes or no?
Sir.
Yes. Now, if you'll observe, though the various objects on this earth attract one another constantly, but they do not cause any motion. Is it yes or no, guys? Yes or no? You maybe notice it. Every object in the universe having force of attraction. That is what we should call it as gravitational force. What we should call it? Gravitational force. Is it yes or no, guys? But you maybe notice it. Even though this force is acting between any two objects in this universe, but it is not, do not cause any motion. Why, guys? Why, guys? Because the gravitational force of attraction between them is very high or very small? Very, very
High, sir.
very high. High means attract.
Small.
High means
Small,
attract.
sir.
It is very small because are you getting understand Varshini? Minus 11, correct? So the force of attraction is coming
Very
very,
small.
very negligible. That is why, even though the force is acting between any two bodies in this universe, it do not cause any motion because of gravitational force of attraction between them is what, guys? Very, very small. Is it yes or no?
Small.
Please respond me. Yes or no?
Sir.
Laksha,
Yes, sir.
Manya, Samaya not joined. Tell them to call them to join. So that is why. So if you'll observe, at least one of the body is large. For example, if you'll take 1 kg object and one very huge object, then what is happening, guys? Gravitational force become what? Very large. Is it yes or no? Yes or no, guys? If the both the
Sir.
bodies are same mass, gravitational force is acting very, very less, negligible. That is why do not cause any motion because of the force of attraction between them is very, very small. But if you take
Small.
one of the object out of two objects, at least one object is understanding. One object is quite larger. Then what is happening, guys? Gravitational force, if very large, if suppose if we take for example like sun or the earth, their masses is very more or very less. Mass of the sun and earth very, very huge. Is it yes or no?
Sir.
Very large.
Yes, sir.
Then you can observe the earth has a, for example, if you take earth, understanding the gravitational force become very, very large because understanding because of what? Earth mass is what? Very large mass, and this force is quite large between the earth and the other objects. That is the reason while you throw apple, while you throw ball, while you throw any pen or pencil, everything fall back to the what, guys? Fall back to the what? Fall back
Ground.
to the earth. Understand? Because the force acting between them is how much, Ra? Very, 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 very big. Very, very big. That is the reason if you'll keep any object, like apple or ball or etc. Understanding, guys? Respond me, Ra. If they will,
Sir.
Yes,
they will
sir.
come what? They will come again towards the earth because of earth mass is very, very big. Earth mass is what, guys? Very, very,
Very, very big.
Very, very big.
Now, as we know that, what is the gravitational force of earth? As we know, any object we used to call it as gravitational force. But if earth is acting, what we should call? Gravity. What we should call?
Gravity.
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 Calculate understanding earth's gravity. So what is this gravity? This gravity also we can call it as gravitational force. Is it okay, guys?
Yes, sir.
Sir.
So gravitational force. Now one more point I should tell you, please note it down. If the object is enough close to the earth,
Close to the earth.
not only earth, any planet which is big in size, one is big in size, one is small in size. If suppose object is here, earth is here, then the distance between them is from their centers. The r is equals to what, guys?
Sir.
R is equals to what? The distance between there from the centers. Is it okay, guys? Please
Sir.
respond
Yes,
me.
sir.
Now, for example,
Yes, sir.
Shruti, you also. For example, if this is the earth, Laksha, remember, and object is enough close to the earth, enough close to the earth. Remember. So anyhow, the size of the object is very, very small. Is it yes or no, guys? Size of the
Yes,
object is
Sir.
so in this situation, we will consider R is equals to capital R. This capital R is equals to radius of earth. What is this, guys?
Radius of earth.
Radius of earth.
Radius of earth. That is, you should remember. Okay, guys? When the object is enough close to the earth, ENOUGH, enough close to the earth. Understanding, Ra? So the distance between their centers is equals to what? Radius of the earth.
Capital R.
Guys, but this R is equals to what, Ramanish? Not radius. What is that? R is equals to distance between their centers. What is that? Distance between their centers. If
Between their
object
centers.
is enough close to the earth, then the distance between their centers is equals to what, guys? Radius of the earth. That is what you remember. If your teachers will say r is equals to d, d is also correct. So when the object is close to the earth, then d is equals to what, guys? What is the Elmokel? Tamil Selvan, Mamanesh?
Radius.
Equals to
of the earth.
radius of the earth. That is, will you remember? Sai?
Sir.
So now let us see. If both the objects are small in mass, the force acting between them is very, very negligible. That is why we are not observing any motion between the objects, even though the force is acting across each and every object in the universe, but we are not observing any motion because the gravitational force of attraction between them is very, 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 very small. But if I want to show the attraction between one object towards the another object, then minimum how many objects are? At least one object should be quite large. Is it yes or no, guys? At least one object of the bodies is quite large. That is what we can say. For example, like sun or earth we can take. Understand? So now let us calculate what is that. What is the gravitational force of earth? We will calculate it now. Is it okay, guys? Shall we calculate it?
Sir.
Yes, now. Calculate the force of gravitation. Calculate the force of gravitation due to earth. Write fastly. Calculate the force of gravitation due to earth. Due to earth. So we are going to calculate what, guys, now? Gravitational force of earth. You may be studying. That value is how much, Ra? 9.8 meter per second square. Do you remember? 9.8 meter per second.
9.81 meter per second square.
10 meter per second square. Yes or no, Elmokel? That value, how it will come? Let us see now. We will calculate it now. Write the question, all of you. Understand, Varshini? Write the question. Calculate the force of gravitation. Calculate the force of gravitation due to earth on a ball of 1 kg mass. On a ball of 1 kg mass. On a ball of how much mass, Ra? 1 kg mass.
1 kg mass.
Laying on the ground. Laying on the ground. Laying on the ground. Laying on the ground. Already you have learned one G value. What is the G value, everybody? Mavanish, Tamil Selvan.
6.7 into
10 power
minus
square meter per kilometer. Now I am giving you another 2 more values. These values also you by heart it. That is mass of earth. Write it. Mass of earth. Today at least in chart you can respond me. Mass of earth.
1 kg mass lying
Mass of earth is equals to 6 into, write it, 6 into 10 power 24 kg. How much, Ra? 6 into 10 power 24 kg. Next, radius of earth. Radius of earth is equals to, please write it, 6.4 into 10 power 3 kilometers. How much, Ra? 6.4 into 10 power 3 kilometers. Okay.
10 power 3 kilo.
We want to calculate force. What is the force formula, guys? Force is equals to what? G into M1
into M2
Understand? Yes or no? Now, what is the question? Read. Anybody read the question? What is the read the question? You have to read the question.
the force of gravitation of all mass of 1 kg.
1 kg. 1 kg lying on the
1 kg mass
1 kg
lying
lying on the where? That is what I want. Lying on the where?
Lying on the
ground.
So 1 kg lying on the ground. 1 kg lying on the ground. So I said 1 kg lying on the ground means in the sense of what, guys? What is the R equals to? What is the R equals to? Anybody? What is the R equals to?
10 power 3.
lying on the ground.
Yeah,
R equal to rate.
understanding. This is imagine M1 and this is earth. So earth is equals to M2. Now in this situation, what is R equals to? I said R is equals to what? Radius of earth. Understand? Radius of earth. Is it okay, guys? Respond me.
I can repeat the question, sir.
Okay. You want question again? Right. Calculate the force of
Sir.
calculate the force of gravitation due to which due to earth due to earth on a ball of 1 kg mass, on a ball of 1 kg mass lying on the ground. Lying on the ground. Is it okay, guys? Now clear? Draw this diagram also.
Yes, sir. Yes, sir.
Darun, respond me. So when I said, when the object is lying on the ground, close enough to the ground, R is equals to what? Distance between the centers is equals to what? Radius of the earth. Is it yes or
Radius
no?
of the
That is.
radius
So
of the
now,
earth.
Yes, sir.
you observe very carefully. Here, they have given in kilometers. So what we should do? We have to make it into meters. Understand?
Meters.
Meter.
R is equals to
Meter.
6.4 into 10 power 3 kilometers. So,
Three.
as we know, 1 kilometer equals to how many meters? Respond me. 1000 meters.
1,000 meters.
1,000 meters.
1000 meters means what? Mavanish, 10 power 3 meters. So, R is equals to, note it down everybody,
1000
6.4 into 10 power 3 into 10 power 3 meters. Is this or no, guys? R is equals to
Yes, sir.
6.4 into 10 power 6 meters. Is it okay? Now, substitute the formula. F is equals to G into M1 into M2 divided by, you have to write R square. What you should write? R square. R is equal to R. Why R is equal to R? Body is close enough to what? Body is close enough to? Understand, Ra? Lying on the ground. That is why. So, substitute the values. F is equals to G value. How much, guys? 6.67. Sorry, 6.7 into. You directly respond me. How much G value? 6.7 into.
1000 into 10 power minus
Newton per kilogram square. Not solving numerical